Good afternoon, honorable judges. We're students of GT College, so today we're here to show that the right kite application on cryptography can produce amazing results, possibly generating a secret message. So what is your perception as a kite? Is it a toy? From Euclid's geometry, everyone would know that a kite is a quadrilateral whose four sides can be grouped into two equal pair sides. Before I go on, I would like to share three views on how people describe a kite. As you can see here, we have three ways to describe a kite using two triangles, and our project is based on the second view most. You may ask, where and how do we get our inspiration? The story behind our project was that one day we were in the library mucking around with the library books, while one of us saw this mathematical book, which is the Euclid's Elements of Geometry, and it will later turn out to be our project. Using the construction skills performed by straight edge and Euclidean compass, the existence of a right kite can be proved when we can construct it. So based on the second view, we can denote a kite by A theta B, where the theta is the included angle between the two distinct sides AB and BC. So for this example, we can call this kite as 375° 5. But since we cannot construct 75° with the straight edge and the Euclidean compass, we choose to focus on right kite. What is more, we can find a right kite when we study tangent properties in school. Luckily, have we found that every kite can be generated from a specific right triangle. So we can now denote a right kite by A diamond B, where the diamond refers to the right angle. Here are the two ways to construct the kite. As we can construct it, we can say it does exist. Now we know the kite does exist, and we can prove its uniqueness by psi angle psi. So, how about the diagonals? We asked. Could we construct a right kite with a given diagonals? And is it a unique right kite? Actually, yes. So the two kites will be formed when we use the diagonals 2x and 2y. As we can see here, we can construct two kites using diagonals. Not only can we construct two kites, we also prove that these two kites are congruent to each other, and the kite is unique. So now we can also denote a kite by A cross B, where AB are the diagonals. Well, not only to solve problems, people study mathematics to admire the beauty of mathematics. So do we. In our project, we admire the beauty of right kite by constructing a spiral with right kites whose sides are in Fibonacci sequence. And don't forget, we can also change the value of the diagonals. Some other patterns can be formed. Moving on, it's time to talk about its application. We would like to introduce you the Poincare disk model, which is a model for hyperbolic geometry, where every line is represented by a circular arc whose ends are perpendicular to this boundary. So as we can see here, these are the lines of the Poincare disk model. And we can see here there are two right kites. We would like to link this up with one of the famous mathematical fields in cryptography. Let's say the message is Hanlong is fun. Our idea is to encrypt this message into a cipher graph. And using the reverse method, we can decrypt this message. But before we do the encryption, we need a table for coding. In this table, each capitalized letter and small letters is represented by as consecutive positive integers from 1 to 52 respectively, while 0 represents the space. So referring to this table, we can obtain the letter by simply compiling any value by x mod 53. For example, A can be any number adding or minusing by 1, just like minus 52 and 54. Without loss of generosity, the Poincare disk model has a radius of 27 units. And applying the coordinate geometry, we set the disk with a center 0, 0 on the coordinate plane. Now we have 4 points that each point carries 2 coordinates, which represents 2 letters. We can refine the order in clockwise and retrieve our message by XAYA, XBYB, XCYC, and XDYD. After compiling the number from 0 to 52, we can decrypt the message referring to the table and get the final message IMGT. So done with the decryption, it's time to talk about the encryption part. Using the same message as example, we have some criteria to be fulfilled. First, the point should locate outside the disk or not, or else there will be no possible lines to be constructed. Also, the points we choose should be in the corresponding quadrants. For the message IMGT, we can get the corresponding code referring to the table, as we have just mentioned. For example, if we want to encrypt capitalized I, then the code will be 9. We have listed out four choices out of infinite possibilities. So these are the 4 ciphergraphs in the form of point k-disk model, all representing the same message, IMGT. The significant point is there are infinite choices in choosing coordinates, which makes this encryption more infinite. Knowing that the graphical transformation method, which we would like to call it GT method, has a delimitation in data length, we try to tackle the problem with dividing it into more quadrants. So, we transform 8 digits to 16 digits. In this GT method, we can obtain 16 digits by adding 2 lines x equals to y and x equals to minus y. If we want to hide a longer message, we can even bisect more lines to increase the quadrant's number. From how we transform 8 digits to 16 digits, it is not hard to deduce that 32, 64 digits can be achieved if wanted. So back to the 16 digits GT method. By choosing the correct point which fulfilled the required condition of these 3 columns, we can be able to encrypt and decrypt a message, referring this table. And these ciphergraphs will represent Hanlong is fun. Even though we have overcame the data length problem, there's still an issue that we will have unclear ciphergraph due to too many lines. So also, if we use a larger number, then it will be harder for us to construct the ciphergraph by hand. So for now, we will just use the computer as a help. Lastly, I would like to wrap up with 2 highlights of the GT method. First, even though we have mentioned there are infinite possibilities in choosing coordinates, we would like to see, what if the chosen point is far away from the disk? After our testing with the aid of computer, it is obvious to see that the behavior tends to the 5th postulate of the Euclid geometry. The 2 tangents will be nearly parallel to each other, and the line of the point k-disk model will nearly to become the straight line and nearly to be the diameter. The second thing is, actually there are infinite possibilities in choosing coordinates. And using this as an example, the same letter group U and N can be represented by 2 totally different XY coordinates, just like which you can see here, H and D, all these 2 points is representing the same letter group U and N. So now we can see how significant GT method is in cryptography. So these are some references of our project. And thank you. This is the end of our presentation.
Thank you very much.
Thank you.